test the effect of various polyacrylates on soil water retention and plant nutritional composition. So what we did was we looked at various polymers and we tried to see which one of these polymers would absorb the most water. So we found that a hydrogel or a polyacrylate, when mixed with water, would create a hydrogel, and this hydrogel would absorb more water because a hydrogel is a three-dimensional network of hydrophilic polymers that can swell in water and they could hold large amounts of water. So we found that a polyacrylate could hold this amount of water, and in this experiment we used two different types of polyacrylates, sodium and potassium, and each of these has its unique property of holding up to 200 to 300 times its weight, and they can hold that much water. So in this experiment we tested the effect of the anions in each of these polyacrylates, and we tested the nutritional composition of the plant because of these anions. And we also tested the water-holding properties of soil to reduce evaporation rates. So our hypothesis was if the soil used for the tomato plants was mixed with different concentrations, then the soil with the higher concentration of polyacrylate will retain the most water and the plant will absorb higher nutrients from the most concentrated polyacrylate. So our experimental procedure was use 24 plants and 12 for sodium and 12 for potassium. And what we did was we had 3 controls in both of these trials, 3 containing 2 grams, 3 containing 4 grams, and 3 containing 8 grams of the polyacrylate. And what we did was we put its respective concentration in each of these plants, and we watered them with 50 milliliters of water. And after about 5 minutes, we waited for the hydrogel to get created in the plant. And then we used a tensiometer and we stuck it all the way in until like the root level of the soil. And then we measured the moisture level in the plant, and you can see that in these 2 graphs, because we can see that in the controls the moisture level is around 2, but then when you up it to 8 grams, the moisture level can move up to 10 grams. And you can see it's an almost linear relationship between the amount of sodium polyacrylate versus the moisture level. And you can also see that in the potassium polyacrylate. And after this, we did this for 5 weeks, and after this 5-week trial, we extracted a tomato from each of these plants, and we extracted 50 milliliters of juice from each of these plants. And we extracted this juice, mixed it with water, and then we put a processor into the solution and held it over the flame to observe color changes, which can be seen in these pictures over here.
So both of these images are controls, but for the sodium we see that there's a light red shade because there's already some sodium present in tomatoes. But with the 4 gram we see there's a darker red, which means that the plant actually absorbs some of the sodium from the polyacrylate. But for the potassium we see that there's actually no change, which means that none of the potassium is absorbed. And so if we look at these 2 graphs over here, we see over 5 weeks that the highest amount was at week 5, which means that over time that more water is being absorbed from the polyacrylates, which means that you could use less water over like in the 6th or 7th week, right? So we can see that the sodium polyacrylates not that ideal to use because it causes a change in nutritional composition. And also after some research, we realized that the sodium polyacrylate actually caused clumping, which we could see in the plant. So when we realized that it caused clumping, the best polyacrylate to use would be potassium, since it did not cause clumping and it did not change nutritional composition. So an extension of this project, we can use it with different variants. So we can use it with magnesium, since that's less reactive with water. Magnesium would actually be like a better polyacrylate, and it would be similar to potassium, where it would have no change in nutrition. So in conclusion, we realized that polyacrylates, that they actually help fight droughts. So in California, we see that 75% of the water used goes to agricultural purposes. If we can use a hydrogel to reduce the water that goes towards the agricultural farming, that we can, and at the end we can create the same end result, meaning that no nutritional composition and the plant grows at the same rate or faster, then we realized that the polyacrylates are effective in fighting the drought and using less water.